We have learned how to graph a line in standard form by plotting the x and y intercepts. In section 1.3.2, we'll learn how to graph lines in slope-intercept form. Before we talk about slope-intercept form, let's review the concept of slope. Remember, slope is the ratio of rise to run. So, slope is basically a measure of the steepness of the line. There's a couple of types of slope that we're going to focus on. So let's examine positive slope and negative slope. A line that has positive slope slants up and to the right, and a line that has negative slope slants down and to the right. So if I'm reading these lines from left to right, then positive slope is moving up and negative slope is moving down. To graph a line in slope-intercept form, we're going to begin at the y-intercept, and we're going to count rise over run to the next point, moving up and right. When we have a line with negative slope, we'll start with the y-intercept, and we'll count down and to the right to measure negative slope. Y equals mx plus b is called slope-intercept form. M, that's going to be a real number, represents the slope. It can be positive or negative, and remember, it's a measure of the steepness of the line. And b represents the y-intercept. So let's practice graphing lines in slope-intercept form. Example 2, rewrite negative 3x plus 3y in slope-intercept form. Identify the slope and the y-intercept as an ordered pair. Then graph the line and label the y-intercept. Now, the line at this point is in standard form. Remember, the form ax plus by equals c is called standard form. We graphed those by finding the x and y intercepts because that was very convenient. Now we're going to rewrite this in slope-intercept form. For slope-intercept form, we need to get y by itself. So we're going to rearrange this equation so that y is by itself. We can do this by adding 3x to both sides. Notice it's going to cancel out over there on the left, and we end up with 3y equals 3 plus 3x. Those are not like terms, so I can't combine them. And to match up with slope-intercept form, it's convenient to write the x term first. So I'm going to write this as 3x plus 3. Now, to isolate y, we need to divide each term through by 3. All 3 terms have to be divided. So we end up with the equation y equals x plus 1. This is our slope-intercept form. Y equals mx plus b. So we want to recognize the slope. Remember, the slope is the coefficient of x. In this case, there's no coefficient, so we understand that to be 1. Often it's convenient to think of your slope as a fraction because it is the ratio of rise over run. So I'm going to think of this as rise 1, run 1. Also, our y-intercept is out here wherever the constant is. So in this case, our y-intercept is x equals 0, y equals 1. So our slope is 1. We're going to think of that as rise 1, run 1. And our y-intercept is 1. So on our graph, we're going to start at the y-intercept 0, 1. Then I'm going to measure the slope, moving up 1 and right 1, and then making a new point. The location of this new ordered pair is x equals 1, y equals 2. Now remember, 2 points are sufficient to determine a line, so you can go ahead and graph that, Or if you want to, you can use the slope as a map to the next point. I'm going to go up 1, right 1, and make a new point. And I can do that as many times as I need to. Once I have a few points plotted, at least 2, I can then connect the dots. And we're going to label the line with slope-intercept form, and we have a graph. Any ordered pair on that line will balance the original equation. Now, let me take you through how to check this on your calculator. If you're unfamiliar with graphing on your calculator, it's a pretty simple process. Anytime you want to graph something, it does have to be in the form y equals. So when I press my y equals button over here, I'm set up for slope-intercept form. Now, if you have anything typed into your calculator, you can clear it out or just type right over it. We're going to type in the equation x plus 1. My variable key is right there next to that green alpha button. When I type that, I get x and then plus 1. Now in the top right corner, I can press the graph button and it's going to show the graph of the line. We can eyeball it to make sure it matches what we did by hand, but also notice above that graph button we have table in blue. To access it, I'm going to press my second key and then my table, and then I can even check ordered pairs. So the first ordered pair that's listed there is 0, 1. That matches up with my y-intercept. We can check the other point that we found. That's ordered pair 1, 2. The next point is ordered pair 2, 3, and that matches this point over here. So every single time I graph, I can double check with my calculator, looking at the shape of the graph and verifying ordered pairs. So please take some time to learn your calculator. It's a tremendous help. On example 3, we're going to practice slope-intercept form again. Rewrite y minus 1 equals negative 2 times x minus 3 in slope-intercept form. Identify the slope and the y-intercept as an ordered pair. Then graph the line and label the y-intercept. We can begin this problem by rearranging the equation in that mx plus b form. So the first thing I need to do is distribute the negative 2 to break up these parentheses. We have y minus 1 equals negative 2x plus 6. Now we need to isolate the y, so we can add 1 to both sides. And we end up with y equals negative 2x plus 7. Notice that is the form y equals mx plus b. So let's identify our slope. Our slope, m, is the coefficient of x, in this case, negative 2. Now notice it's just the coefficient. It's not negative 2x, it's just the coefficient. We want to express this as a fraction to make our graphing easy, so we'll write it negative 2 over 1. Our y-intercept then comes from this number out here, and as an ordered pair, it would be x equals 0, y equals 7. So we can plot these on our graph. Remember, we begin at the y-intercept, 0, 7. And this time, we're looking at negative slope. So instead of going up and right, we're going to go down and right. So we're going to go down 2 and right 1. So I'm going to count down 2 from my y-intercept and right 1, and then make a point. So this ordered pair then would be x equals 1, y equals 5. Again, you can plot as many points using the slope as a map, down 2 and right 1. This would be ordered pair 2, 3. Once you have as many points as you like, remember 2 is sufficient, then you can connect the dots in a straight line and label your line y equals negative 2x plus 7. Remember, you can verify this with your calculator, so let's practice that again. I'm going to press my y equals button, and I'm going to clear what I had typed there previously and type in negative 2x plus 7. I'm going to type the graph button to see a visual of the shape of the graph. Again, you can verify points by looking, or you can access your table function by pressing second table. And you can work your way through this table using your up and down arrow keys. So notice we have ordered pair 0, 7, that was our y-intercept. We have ordered pair 1, 5, that matches up with what we found, and ordered pair 2, 3. So now you have two methods for graphing a line. If it's in standard form, we're going to use x and y intercepts. So standard form, we're going to graph x and y intercepts. And if it's in slope-intercept form, we're going to graph with slope and y-intercept.